Okay, so we're going to look at the polar form of a complex number. Okay, so already we know how to get rectangular form. So rectangular form is the way I've written that the complex number here is z. So it's 1 plus 3, and obviously I should have an I here. So rectangular form means you're just using like a rectangle, so over 1 and up here to root 3. Okay, so there's 1 plus root 3 I. Okay, so over 1 on the real axis and up root 3 on the imaginary axis. Okay, now I'm not worried about scales or anything here, I'm just worried about wondering about the position. Now we call that rectangular form because, like I said, you went over here and up. Okay, so you can see that that would form a triangle if I complete it. Okay, so that's called rectangular form. Now, polar form is looking at another way of getting to that number. And another way of getting to that number is going out by some amount and then swinging an angle. Okay, here. So there's our angle theta. So you come out some radius r and you swing an angle theta. Okay, so this is your radius r that we go out and we swing an angle theta, and then our complex number is then equal to z equals r cos theta plus I sine theta, where r is called the argument. Sorry, r is called the modulus, i.e. the length of the complex number from 0. And theta here is called the argument, or arg for short. Okay, so the only thing now we have to be able to do is, how do we actually figure out what the modulus and the argument are? Well, from the way it's written in rectangular form, it's very easy to change it into polar form. So r is the length out from 0. So we looked at this before, because r is simply equal to the square root of a squared plus b squared. So this is when a number z is equal to a plus bi, then r is equal to a squared plus b squared. So you're simply using Pythagoras' theorem, because you're seeing how far out do I go and how far up, and the length of the complex number then is this dotted black line, which is obviously the hypotenuse of that pink triangle. Okay, so filling in those numbers, I have r is equal to the square root of, now my number was 1 plus root 3, so 1 squared plus root 3 squared. So when I work that out, I'm going to get r equal to the square root of 4, which is 2. And then, so that's the r part, and the next thing then I need to work out is the angle. Okay, so the angle theta is equal to, now if we look at our diagram, we actually know, just to rub out this to make it clearer, we know two parts of this triangle. So we know how far out we came. So that was, if the number is 1 plus root 3i, which we can see here, we can see that we came out a, which is 1, and we went up root 3, which is b. So we have those two sides of the triangle. So an inverse tan will give us those. Now I'm going to put absolute values on them. It doesn't matter here because they're both positive, but in further, when the complex number is in other quadrants, those numbers won't be positive. And always remember, when you're finding a reference angle, the reference angle always needs to be less than 90 and it always needs to be positive. Okay, so root 3 over this, inverse tan of that, you look that up in your tables book on your calculator and you'll get pi over 3. So this implies then that that complex number, 1 plus root 3i, can be written as r, which we found to be 2, by the cos of theta plus I sine, cos of pi over 3 plus I sine pi over 3. So like we said, we refer to this one as rectangular form, and this one here as polar form. Okay, so I'm going to show you how you can do these on the calculator as well, so just so you can check your answer. So we can see here that my answer is for 1 plus root 3i, I have an answer of 2 times the cos of root 3 pi over 3 plus I sine pi over 3. So we go shift and pol, and we enter our complex number as 1 comma root 3, no i's, press my close my bracket and press equals. Okay, so straight away it gives me r equal to 2, and that theta is equal to this decimal that doesn't look too nice. All I have to do with this is, the calculator, if it has two answers, automatically stores the answers in x and y. So it'll store the first one in x, which is r equal to 2, and it'll store the second one in y. So if I recall y, using shift recall and y, okay, I can see here that it'll press my equals, it brings up my y to be pi over 3. So you add your r to be 2, and now you can see that your argument is pi over 3.